Hello. Welcome back to the channel. In this video, I am going to discuss Cambridge International AS Level Physics, Paper 3, which is Advanced Practical Skills 1. The paper that I'm going to discuss in this video is May-June 2022, Paper 33. So let us get started with the first question itself, right? Now, first question, right? Read the instruction. You have to read the instruction very carefully. Instruction stated that you may not need to use all of the materials provided, right? Just follow whatever they ask you to do. Now, the first question itself. In this experiment, you will investigate an electrical circuit. You have been provided with a wooden strip with a wire attached to it. A. Measure and record the length L of the wire between the nails on the wooden strip. So everything has been set up for you. All you need to do is just to take your meter rule and just place the meter rule from one nail to the other nail and measure your length. Now, before I write down my answer, right? Before I write down, you have to understand this is your paper 3. Paper 3. Right, the important thing about the paper 3 is the significant figures, the decimal points always confuse a lot of the students, right? Now, I want you to remember one simple thing. Whenever you use apparatus, first thing, before you write down your reading, write the reading from you because you're taking the reading from the apparatus. So before you write down your reading, first thing has to appear in your mind is what is the absolute uncertainty? Absolute uncertainty in paper 3 means the sensitivity or the smallest division of that particular apparatus. Now, since L, we are supposed to use a meter rule to measure L. So what is the smallest division of the meter rule? Smallest division of the meter rule is 0.1 cm. Therefore, the absolute uncertainty of your meter rule is plus minus 0.1 cm. Before you write down the value of L, make sure that your reading must be recorded based on the decimal point. Measured data, because L is a measured data, so you have to follow the decimal point of the absolute uncertainty of that particular apparatus. Now, I got 75 cm, so I put 75.0 cm. Why? Because the absolute uncertainty of the meter rule is one decimal point. So my reading will take one decimal point together with a unit in order for you to get that 1 mark. B, you have also been provided with a wire labeled A with crocodile clips at its end. Set up the circuit shown in fig 1.2. So you set out everything, crocodile clips, you just clip, and then, right, G, H, J are being labeled, right? And the switch is being given, and this is 1.5 volt DC. Normally they will give you the power supply. So you just turn to 1.5 volt. Right? Why? They will be giving you 2 voltmeter. So the voltmeter that I have here is this one. This is called digital voltmeter. So you can turn to V to measure the potential difference. F, G, H, and J are crocodile clips. Distance between one of the nails and H is D, as shown in fig 1.2. Attach H to the wire on the wooden strip so that D is approximately 20 cm. They have already mentioned approximately, almost similar to 20 cm. Close the switch and record the value of D. D approximately, that means almost similar to 20 cm, can be a little bit more than 20 cm, can be a little bit lesser than 20 cm, but not too much more than 20 cm and not too little as compared to 20 cm. So I measured just nice 20 cm, but hey, remember D, what is D? D is the length. So we are using meter rule again. Remember, first thing, meter rule, what is the absolute uncertainty or the sensitivity or the smallest division of meter rule? It is plus minus 0.1 cm. So if you want to write down, okay, you can write down just beside it, just for you to remember, right? So this is called measured data. Measured data must follow the decimal point of the absolute uncertainty of the apparatus. So 0.1 cm. That is why I have to make sure my D is in terms of one decimal point. So this is 20.0 cm. V1, remember just now I showed you the voltmeter that I'm using. This is a digital voltmeter. So the sensitivity of the digital voltmeter for V1 and V2 is plus minus 0.01 volt. Therefore, my readings on V1 is 0.24, 2 decimal points, volt, and V2 is 0.52 volt. Done. And open the switch, right? C, increase D by placing H at different positions on the wire and record V1 and V2. Repeat until you have 6 sets of readings of D1, V1, and V2. Include your values from B and record your results in a table. Include values of V2 divided by V1 multiplies by D and D squared in your table. Now, the first thing that you need to write on your table, because the question asks you to include, right, the values from B. So I'm going to write down the heading. I'm going to write the heading for the table first. They ask us to put the D value. So D, this is a symbol, slash the unit. And if you want to put together with the absolute uncertainty, you can do it, but you have to do it like this here. Let me write it down. Okay, I normally do like this to avoid making careless mistake. So I know D, I use ruler, so I have to denote my reading in terms of 1 decimal point. And then after D, this is V1, okay, voltmeter reading slash the unit. And if you don't want to put plus minus, right, it is up to you. It doesn't matter. 0.01 volt. I just want to put it in all to avoid me making some careless mistake. And then V2 slash unit, and then plus minus 0.01 as well, volt, because I'm using digital voltmeter. And then after that, this is V2 divided by V1 and times multiplied by D. So the unit is cm. Because V2 volt divided by V1, which is also volt, there's nothing. And then multiplied by D. D is measured in cm. And then D square, so D square slash the unit is cm square. Done. I don't put plus minus for V2. I don't put absolute uncertainty for V2 over V1 times D or and D square. Why? Because V2 over V1 times D and D square are called calculated data. So for calculated data, we have to look at the significant figures of the raw data. So I'm going to write down my answer. So the first D I got was 20, but I have to put in 1 decimal point, remember? So the second D I put 35, actually 35. And the third D I put 50. And the next D, I put 60. It doesn't matter whether the difference between the D values are not in sequence. It doesn't matter. So different, right? It doesn't matter as long as you get that value. They don't really look at the sequence. Oh, the difference between the first value and the second value must be consistent all the way. No, no, right? And then I put 70 cm. And then last one, I put 80 cm. So I have 1, 2, 3, 4, 5, 6, 6 sets of readings. And V1 value, the first one I got 0.24, and then V2 I got 0.52. Sorry, 0.52, not 50, sorry. This is 0.52. And then this is 0.27, 0.29, 0.36, 0.45, 0.58. Here I got 0.30, 0.19, and then 0.16, 0.12, and 0.09. All these are 2 decimal points. And after that, okay, I do my calculation. Here I got V2 divided by V1 times D. Look at V1 and V2. V1 and V2 are both two significant figures, and my D has three significant figures. So I can choose to put 2 to 3 significant figures for V2 over V1 times D value. Instead, I choose to put three significant figures, right? So the first one I got 43.3. The next one I got 38.9. Okay. And then this is 32.8. And then this is 26.7. And then this is 18.7, and then this is 12.4. D square, you have to look at D value because D square is a calculated data. So all the D values are of three significant figures. So I have to put three significant figures to D square. So the first one, 400, second one is 1230, and third one, 2500. 3600, 4900, and 6400. Done. And then after that, D1, part 1, plot a graph of V2 over V1 times D on the y-axis against D squared on the x-axis. And you have to draw the straight line of best fit and determine the gradient and y-intercept of this line. So I have already drawn, I label. So for graph, you will be given 3 marks, right, for the graph. So you have to make sure that your axis, scales, right? And especially the number of boxes, okay? You have to make sure that all your points scattered at least half of the graph paper. So normally the graph paper that they provided you with has 12 boxes vertically, so you need to use at least 6 boxes. Make sure that all your points scattered around 6 boxes altogether. You see all my point here: 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 7 boxes. So I'm safe. So on your x-axis, you will be given 8 boxes altogether. Make sure that the scattering of your points must be at least half of the graph, right? At least 4 boxes. So I have used 1, 2, 3, 4, 5, 5, 6 boxes. So I'm safe, right? So these are all the points plot on your graph, right? I have already plotted. Now I'm supposed to find the gradient. So remember, gradient, you have to draw this triangle. So for the examiner to see, gradient, the triangle must occupy at least half of your straight line. So that is why it is suggested that you draw as large as possible. Your x1, y1, and your x2, y2 are separated by far distance on the straight line. And one more thing that I have to remind you, some of the students were asking whether is it okay if they take the value, right, from the table. That means the values that they have already calculated, the points, the coordinates that they have already calculated on the table. So I would strongly suggest that you not to. Why? Because not all the points lie on the straight line. So to play safe, in order for you to get a more accurate value, I would strongly suggest you to take the points on the straight line only. Now, since I already, okay, got my two coordinates here, I'm going to find a gradient. So I'm going to write the gradient here. Gradient. So you remember the equation of gradient? Y2 minus y1 over x2 minus x1. And I am copying down my coordinate. One is 1,139.5. 1100, 39.5. And the other one is 6,810. 6,810. So the gradient would be, I get 39.5 minus 10 divided by 1,100 minus 6,800, right? So just check 39 minus 39.5 minus 10, 1100. minus 6800. So 39.5 minus 10 divided by 1100 minus 6800. And I got negative, of course. My answer was negative 5.17. Okay. I just put more significant figure. Okay, never mind. I just put in terms of three significant figures. 5.18 times 10 to the power of negative 3. Right? It doesn't matter if you don't put unit for a gradient because gradient is math. Normally, we don't put unit for gradient. Right? So my answer is negative 5.18 times 10 to the power negative 3. Now, what about y-intercept? I would love to take my y-intercept to read off from the graph, but I couldn't do that. Do you know why? Because I didn't start my point, I didn't start my y coordinate from 0. I start from 10. No choice, so I have to do substitution. Do you should remember what does it mean by substitution? Since this is a straight line graph, therefore it will follow the straight line equation y equals to mx plus c. So you just take any points that you like on the straight line. Since I have 1 point here, 2 points here, so I take this 6,810, right? Y-axis is 10. Gradient, I got the value 5.18 times negative 5.18 times 10 to the power negative 3. So x-axis 6,800 plus y-intercept. So my y-intercept would be times 6800. Then okay, so my y-intercept would be 45.2, 45.2. So I just write down 45.2. That's it, right? Only if you start your y-axis with 0, you can read off from the graph for your y-intercept. But if you start for any other values, no choice, you have to follow substitution. You have to follow my way, y equal to mx plus c, and you sub in one coordinate into the equation to get the value of your y-intercept. Now, part E, it is suggested that the quantities V1, V2, and D are related by the equation V2 over V1 times D is equal to PD squared plus Q, where P and Q are constants. Use your answers in D, part 3, determine values for P and Q, and give appropriate units. Now, units are very important. Now, since I have this, I know that this is my y-axis, and then I know that compare with the straight line equation, right? The general equation of the straight line. So this is your y-axis. Can't you see that P represents gradient? Because x-axis is d squared and Q represents the y-intercept. So make things easier. So I would write P is equal to gradient. Therefore, the value of P is negative 5.18 negative 5.18 times 10 to the power of negative 3. Remember, units are very important. How do you calculate gradient? Gradient is y-axis divided by x-axis. So cm divided by cm square. So cm divided by cm square. Can you see that? So the unit of P is per cm, cm to the power negative 1. So I just write down the answer. 5.18. The unit of P is cm to the power negative 1. Whereas Q is y-intercept. Y-intercept. Remember, what is the value of y-intercept? Just take from here, 45.2. And what is the unit? Unit is on the y-axis. So you just look at the y-axis. It is in cm. So just put it in cm. 45.2 and the unit is in cm. Done. Now F, a wire A has the same length L as the wire between the nails. Theory suggested that P is equal to negative 1 over L and Q is equal to L. A student repeats the experiment using two shorter wires of equal length. Okay, this is a key word here. Using two shorter wires, right? But equal length. So if the wire is shorter, what happened to the L, right? Sketch a second line. Okay, now you can see that L decreases. Okay, these two wires shorter, but these two wires are of equal length. Do you get it? So L decreases. Now let us look at P. P is equal to gradient. Now, when L decreases, what will happen? Because P is inversely proportional to -1 over negative L, right? So that is why when L decreases, P would have to increase. So when the P increase, gradient is steeper. P increases, gradient would be steeper. What about Q? Q is a y-intercept. Y-intercept. So what happened to the y-intercept? When the line decreases, y-intercept will be lesser. So the second line that you are supposed to draw a shorter line but steeper. Okay, y-intercept is lesser, but it has to be steeper. Okay, must be steeper, cannot be. Okay, steeper, that means towards straight, towards y-axis, yeah? So I'm going to draw steeper a little bit. So y-intercept, okay, maybe this line. I'm going to use red color to draw so that you can see it. So this is my line. Okay, okay. Now this is, oh, okay, I put it here. So this is it. So this is the second line that you are supposed to draw. See that? And we are done with the first question. Right? Now, the second question. In this experiment, you will investigate the motion of two connected masses. You have been provided with two masses connected by a string, and the larger mass is 100 gram and the smaller mass is 10 gram. A part 1, set up apparatus as shown in Fig 2.1. So you just set up, you have a rod, right? And then you have this mass over here, and then you have a string connected to it, and the string will be, the other end of the string will be connected to 10 gram mass. So you hold the 10 gram mass. Remember, this second experiment is full of error. That is why they never ask you to plot the graph, because all the points will go haywire, so you cannot plot a nice graph, right? Now, let us read the instruction. Hold the 10 gram mass so that the string is horizontal and as straight as possible. Yeah, and the 100 gram mass is as close to the rod of the clamp as possible. The string should be resting on the rod of the clamp. When the 10 gram mass is released, the 100 gram mass will fall downwards. So you release, you let go of it, the 100 gram, because there's nothing to hold it, so the 100 gram will fall due to the gravity, right? Downwards, the 10 gram mass will fall and move towards the stand. And the string will wrap itself several times around the rod of the clamp. You may need to repeat this procedure several times before you see this result. So sometimes, right, due to the winds or small movements, something like that, right? So you might not get that mass to wrap around the stand, to the clamp. Now, release the 10 gram mass. The distance fallen by the 100 gram mass is A, as shown in Fig 2.2. Measure and record A. So A is the distance. Remember, it is a distance. When it is the distance, you bear in mind you are using a meter rule. So first thing you have to remember, what is the absolute uncertainty of the meter rule? It is plus minus 0.1. Therefore, your A readings will take 1 decimal point. Right? So remember the question stated that, the instruction stated that you have to repeat several times. Right? That is the reason why they give you 2 marks here. So first attempt. So you calculate, okay, you measure A1. I get 48.3 cm. A2, I get 47.9, quite big difference. And then I find A average, right? Which is equal to 48.3 plus 47.9 divided by 2. And I round it off to 3 significant figures. Why? Because my A1 has 3 significant figures and my A2 has 3 significant figures as well. So I got 48.1 cm. So 48.1 cm is my answer. And the second part, estimate the percentage uncertainty in your value of A. And you have to show your working, right? Do you still remember AS? You have learned about percentage uncertainty of A. It is delta A over A times 100%. So when we are asked to estimate the percentage uncertainty of A, so you have to ask yourself, right? This is about you as the experimenter, right? When you conduct this experiment, how do you find this experiment? Because this experiment, right, the wire, or I mean the string, may not be able, right, to wrap itself around the clamp, and then the 10-gram mass, okay, or sometimes, okay, the string might be snapped, or the 10-gram mass, right, moving here and there. So it's very hard for you to measure A. Look at my A1 and A2 values. They are different values. Why don't I get the same values? Right, why don't I get the same value? It is because I know that this experiment is full of error. It's very hard to measure A. So I would like to increase the absolute uncertainty of my meter rule. Yeah, because this experiment itself is about something that is moving. The masses are moving. So in order for me to measure that length, I need something to be static or stationary. Since the masses are moving, which makes the meter rule, which make me, yes, as an experimenter, to face difficulty in measuring A. So I would like to increase the absolute uncertainty of A to maybe 0.5, right? Quite large error. So I increase my delta A to 0.5 divided by A value times 100%. I am still following the AS syllabus. Percentage uncertainty can only take 1 to 2 significant figures. So I'll keep that, right? So I am going to put it in terms of 2 significant figures, which is 1.0%. And B, Fig 2.3 shows the 10-gram mass held so that the angle between the string and the vertical is theta. So the first part, hold the string so that theta is approximately 65 degrees. Release the 10-gram mass. The distance fallen by the 100-gram mass is h as shown in Fig 2.4. Measure and record theta and h. So since they asked us to measure so that the theta is approximately 65, I try my best. I get 65. You could get 64 maybe, right? Or 66, just a little bit more than 65 or just a little bit less than 65. It doesn't matter, right? The h that I got was 52.2 cm. Put a unit. And then calculate cos square theta and h over a, cos square theta, cos square 65. And I got, since the theta has 2 significant figures, that is why my cos square theta would take 2 significant figures, 0.18. H over a, h is 52.2. I guess 52.2, and the A I got 48.1. Let me do my calculation. 52.2 divided by 48.1, and I got 1.09. I put 3 significant figures. You know why? Because H has 3 significant figures and A has 3 significant figures as well. So 1.09 without the unit. Now repeat B1 and B2 with a value of theta approximately 45 degrees. So I put 45 degrees here. And the H that I got was 55.6 cm. And my cos square theta, so cos square 45, since 45 has 2 significant figures, that is why I put cos square theta as 2 significant figures, 0.50. H over A. H I got 55.6. A is still 48.1. And I got 1.16. Three significant figures. Why? Because H has 3 significant figures and A has 3 significant figures. Now, D, it is suggested that the relationship between H, A, and theta is H over A is equal to K cos square theta plus 1, where K is a constant. Using your data, calculate 2 values of K. Now, I make K as a subject first. K is equal to H over A minus 1 and divided by cos square theta. I find my first K. K1 is equal to H over A, part 1, yeah? It is H over A 1.09 minus 1 divided by cos 65, which is equal to 0.18. Okay, and I got, wait, let me see, 1.09 minus 1 divided by 0.18. So I have 0.5 as my answer. So I would like to put it in terms of three significant figures because 1.09 is three significant figures and 0.18 has two significant figures. Right, so I choose to put K as three significant figures. Now, K2, I have H over A 1.16 minus 1. 1.16 minus 1 divided by 0.5. And I got 1.16 minus 1 divided by 0.5. And I got 0.320. Now, first value of K is 0.500. Second value is 0.320. And bear this in mind, you can put the two K values in terms of two significant figures, not a problem. And justify the number of significant figures that you have given for your values of K. So I say H over A has three significant figures. Cos square theta has two significant figures. So hence the number of significant figures that given for K values is three significant figures. Done. You can choose two significant figures, not a problem. Now, E, it is suggested that the percentage uncertainty in the values of K is 20%. Using this uncertainty, explain whether your results support the suggested relationship in D. So, percentage uncertainty of K. How do you calculate? You take the larger K value minus a smaller K value. So, in this case, it is K1 minus K2 divided by the smaller K value times 100%. So 0.5 minus 0.32 divided by 0.32, and I got 50. 0.5 minus 0.32 divided by 0.32 and times 100%, and I got 56%, two significant figures. And okay, since percentage uncertainty, just write down in values of K is 56%, which is larger than 20%. Hence, okay, result do not support the suggested relationship. That now the last part, which is the hardest part to score. Now F part 1, describe four sources of uncertainty or limitations of the procedure for this experiment. For any uncertainties in the measurement that you describe, you should state the quantity being measured and the reason for the uncertainty. Remember, right? So I will state one uncertainty and then I will state one limitation and give you the suggested improvement. right? So the first one, which is the standard one, it is true for all the experiments. So I would strongly suggest you to memorize this. 2 readings are not enough to draw a valid conclusion. So as an experimenter, as a physicist, you definitely know that you cannot just depend on 2 readings. You have to conduct so several readings, multiple readings in order for you to test the relationship. Yeah. So the improvement is take more readings and plot the graph. Don't say find average because all the experimenters supposed to do that. And plot the graph to see the relationship. Done. Memorize this, right? And the second one, they ask us to measure the angle. I have one hand holding and the other hand is holding a protractor to measure the angle. So my protractor might not be aligned, right, nicely. So that is why I would like to talk about that, right? Hard to measure angle theta. So how am I going to do about that? So I will say clamp a protractor behind the string. Clamp it right away. I don't have to hold it. And then I would say that because, right, when the 2 masses are moving, right, so my retort stand might not be stable. So my retort stand keep on moving, okay? Retort stand keep on moving due to motion of masses. So suggestion is that use a G clamp to clamp retort stand to the table. And then do you should remember when you hold the string initially, you have to hold it as horizontal as possible. How do you know that that is horizontal, right? Hard to judge whether the string is horizontal. That is my last one. Hard to judge whether whether the string is horizontal. So what are we going to do about that? Do you know there's an apparatus? We call it as spirit level. So we can just place on top of the clamp or the rod to make sure which is right same horizontal line as the string to make sure that the string is horizontal, right? So I would say place a spirit level on rod, okay, to make sure string is horizontal. So that is all about the discussion on our paper 3 practical paper, which is May June 2022 paper 33. So I hope you gain benefits from that. So please do subscribe and support and like. Thank you very much for watching, and I will see you in my next video. Bye.